In this lesson, we're going to be talking about three things: continuity, end behavior, and even versus odd functions. Our standard that we're working on is really the same that we've been working on, and it's really looking at key characteristics of functions. And so this time we're going to be focusing on symmetries and end behavior. So first, let's go ahead and go over something called continuity. So a graph is said to be continuous if there are no breaks or holes in the graph. If there are breaks or holes, then it's considered to be discontinuous. Now you can kind of think of it like tracing over the graph. So if I went ahead and I put my pencil here on starting on the left and I trace this graph, would I have to move my highlighter by jumping over something? And if I ever have to jump, then I know it's discontinuous. So there are three basic types of discontinuity. This first type is defined as when f of x increases or decreases infinitely as x approaches x equals a from the left to right. Real wordy, I know. So let's go ahead and break it down. So first of all, let's hope that we remember that x equals a is the equation of a vertical line. So if it looks like somewhere there is some type of vertical line in the graph, then it's a point of discontinuity. So if I'm going ahead and I'm looking at this graph from the left, I'm going towards negative infinity right about here. And from the right, I'm going towards positive infinity right about here. It's like this vertical line right there about where a is, or whatever value of the x-axis that is, right there where that vertical line is passing through, okay, seems to be where the two sides are meeting up, but they don't cross over it. So that's what the discontinuity means. So from the left, it's going towards negative infinity, and from the right, it's going towards positive infinity. And so we have a type of discontinuity, which is called an infinite discontinuity. Another type of discontinuity has that word in it, jump. And that's kind of like what happens. It's like when you jump from one part of the function to another part of the function. Now notice there's this hole here, but there's a closed circle right here. And that's because this point right here, that xy value is part of the function. This xy value here has the same x, but a different y, but because of the open circle, this is not part of the function. So what it says is from f of x jumps from one point to another at x equals a. So they're both lined up. So my domain here is all real numbers, but my range, when I get to this point right here, my range isn't continuous right there. So it's called a jump, not a technical term. And this type of discontinuity is literally called a hole. And see the little hole right there? Okay, what it says is that it's continuing, but I gotta skip that point right there. So I skip that value for my domain and that value for my range. Now let's look at some examples. So we want to determine if the function is continuous or not. So let's just go through them really quick. So if I see this, it's not. If I'm not skipping anything, it is. I'm having to jump, so it's not. Not skipping anything. I got a hole, and this one has two things. I see I have a hole, and I have an infinite discontinuity, so this one's not continuous. Okay, so now we want to identify. So right here, it was a jump. Here, I have that vertical line where they're approaching. So this one is infinite discontinuity. I'm going to abbreviate. This one just had a hole, and this one had both a hole and it also has that vertical discontinuity. So it's infinite discontinuity as well. Now we're going to talk about end behavior. End behavior is something that's really important, especially because this class is titled Pre-Calculus. When we get into calculus, we're really going to talk about something called limits and how limits and end behavior are actually interconnected. So when we're talking about end behavior, we're talking about the extreme ends of the function. So where those arrows are on the left and the right. Now one thing to make note of, how we go ahead and what this symbolism here means. So we're talking about as x moves towards positive infinity and negative infinity, and behavior describes what's happening to the value of y, or f of x. So x approaching positive infinity is the right side of the graph. So it's just the proper symbolic notation of saying the right end behavior of the function. So that means the left side is x approaching negative infinity, because remember, as we go to the left, x is getting more negative. As we go on the right, x is getting more positive. So as x approaches negative infinity is the fancy way of saying the left extreme of the graph. So let's look at what our graph is doing. So here on the right side, x is approaching positive infinity. And what are my y values doing? They're decreasing and decreasing and decreasing and decreasing until, and I have no limit for how far I'm going, so it's going towards negative infinity. Over here on the right side, as x is getting more negative, y is getting bigger and bigger and bigger, so it is going towards positive infinity. I like to put the plus sign when I'm doing end behavior and limits later on, so it's okay to put the plus sign there. Okay, so now let's go ahead and we're going to look at number 7. So here's x going towards positive infinity, or the right side. And that arrow tells me which direction is my y values going. It's going towards positive infinity. As x goes towards negative infinity, it's the left side. And I see that arrow is telling me it's continuing to increase. So it also, as x goes towards negative infinity, it's also going toward, y is going towards positive infinity. Okay, now let's look at number 8. So this is my right side over here, where x is going towards positive infinity and y is doing that, which means it's going towards negative infinity. So now over here on the left, that means x is going towards negative infinity. But what are my y's doing? They're decreasing, which means they also are going towards negative infinity. Number 9. Okay, again, when we're talking about end behavior, we're talking about extreme left, extreme right. Now let's look at number 9. And remember again on number 9, just to kind of look at things. There's 4 arrows on here, which can sometimes be confusing, but we're looking at the extreme right and extreme left. So on the extreme right side, what is my y doing? It's going towards positive infinity, and the right side, remember, is x approaching positive infinity. On the extreme left, x is going towards negative infinity, and y also is going towards negative infinity. Okay, now in these examples, I'm only just going to pick on a couple of them because I want you to see that sometimes the end behavior doesn't always have to go towards infinity. So let's look at 2 of them. So I'm going to look at number 10, and then I'm also going to look at number 12. So when I'm going ahead and I'm looking at number 10, I see that as I go towards negative infinity, my graph is getting horizontal. And on the right side, it also is getting horizontal. But it's not crossing that x-axis. So my x-axis represents all the values of y that are exactly 0. So that means my y values are never getting to 0, and they're never going above 0. So what's happening is, as these points continue to the right, they're getting closer and closer and closer to an output of 0. And on the left, the same thing. So we would say, as x approaches positive infinity, f of x is approaching 0. And as x approaches negative infinity on the left, f of x is approaching 0. Now we're not done, because we have to talk about which side of 0 are we on. So if we're below the x-axis, we're approaching the negative side we're from the negative side of 0. And if we're above, we're approaching from the positive side of 0. And that's because the numbers are getting bigger when we go up above 0, and they're getting smaller as we go below it. So when we're talking about approaching 0, we have to say which side we're on. Okay, so on the positive infinity side, I'm approaching it from below y equals 0, so that means it's the negative side. And the same side is where I'm approaching as we go towards negative infinity, so we would say that one. And let's look how that's a little bit different on number 12. So on number 12, I also see that they're getting more and more horizontal. And so I'm drawing in my horizontal line. And what it looks like is that horizontal line is right there where y is equal to 2. So remember, we're looking at the extremes, so the left side and the right side. Now, just to switch it up a little bit, because it really doesn't matter if you go left side or right side. I like to go left to right. So as x approaches negative infinity, which is the left side, my y value is getting closer and closer to that line right there. And just as an FYI, that line is technically called an asymptote. And we learn about asymptotes when we go through rational functions again, and exponential functions, and logarithmic functions. So my y value, or my f of x, is approaching 2, but from which side? Well, it's under, so that means it's the negative side. As x approaches positive infinity, that means I'm going on the right side now. What's happening is it's getting closer and closer to 2 as well, except this time it's not coming from below, it's coming from above. That's the positive side. Switching gears a little bit, we're going to have a little throwback to geometry, and we're going to talk about symmetry versus end functions. So there's an algebraic way to test for symmetry, just like there was a way that you talked about it visually when geometry. So one thing that we know about is there's vertical symmetry, or line symmetry, I should say. And specifically when we're talking about functions, we talk about vertical symmetry and horizontal symmetry. Some functions have it. Now this is point symmetry. Point symmetry is when you can rotate about the point so that 180 degrees and you end up with the same looking graph. So the x-axis gives us horizontal symmetry, and the y-axis sometimes is our line of symmetry. That's the vertical one. They're commonly going to be lines of symmetry, so much so that they have very special uses. The origin is also a common point of symmetry for some graphs. So this is point symmetry because it's about a point. And this is line symmetry. Remember, horizontal, vertical.